Okay.
So in our data warehousing and data mining paper, in the first module, we were talking about the introduction to data warehousing. We discussed all these concepts, what is the evolution of database models available. Then we also talked about what are the different information systems generally used in an organization, and the data warehouse will be required by the executive support system as well as by the decision support system. Then we also talked about what are the different characteristics of data warehouse, which is very important. So any database that contains these four characteristics can be called as a data warehouse. Then we also talked about some of the key characteristics of a data warehouse. Then we also discussed how the data is to be integrated. What are the two major what you call architecture of integrating the data sources. One you call as on demand, or it is also called as virtual system. The other one is called as in advance, which is also known as materialized system. So these are the two ways of integrating the data. Then we discussed very briefly what is the difference between data warehouse and database. Then we talked about what are the different types of data warehouses we will have. Then we also talked about why we need to mine the data and what do you mean by data mining. What is the origin, right? What are the base concepts that are used by the data mining, and what do you mean by data mining and what is not data mining. So these are the different concepts we discussed in our previous sessions. Today we are going to talk about the multi-dimensional data model, which is a very important concept that is coming in data warehouse. Now, if you take the multi-dimensional data model, all the data mining tools are all the OLAP tools. When I say OLAP tools, they are all used for analytical processing, and we collect the data in the data warehouse only for analyzing the data, right? It is not used for transactional processing. The data warehouse content is used for analysis, right? You want to analyze something, then you want to extract the pattern from the existing data. So that is why we use a data warehouse. Now, whenever I say I am going to analyze the data, the analysis will not be based on one particular dimension. Instead, the analysis may be based on more than one dimension. Say for example, I want to analyze the sales of a particular organization. Now what we will do, you want to analyze the sales based on the what you call time, or you want to analyze the sales based on the branches of an organization, or you want to analyze the sales based on the items in that particular market, or you want to analyze sales based on a particular location. So from this particular location, how many customers are coming in, how many customers are purchasing a particular item from a particular location, right? So you want to analyze one particular subject based on different dimensions. If so, it is not enough to store the data in a two-dimensional format. Instead, I need to store the data in a multi-dimensional model. So all the data warehouses will store the data in the multi-dimensional data model. Only then the analytical processing tools can use it. Now, if you take the multidimensional data model, it is going to view the data in the form of a data cube. It will be viewing the data. Now, please understand, I am not going to store the data as a cube. I am not going to store the data as a cube. Obviously, You can store the data only in rows and columns, right? Inside the computer, in the digital storage, we can store the data only in rows and columns. Whereas when the application is viewing the data, it is going to view the data in the form of a data cube. So that is why the multidimensional data model is sometimes called as multidimensional view data model. I'll be asking you questions based on the lecture also. So please take down the points as well as the explanation. So these data cubes will allow you to view the data in multiple dimensions. So that is the advantage of having the data cube. Data will be stored in a two-dimensional format, but it is going to be viewed in multiple dimensions. That is the advantage. Now, whenever I say multi-dimensional data model, it is generally defined by two terms. One is called as dimension, the other one is called as fact. Dimension and facts. These are the two terms we will be using in the multi-dimensional data model view. Now the question is, why I need to have a multi-dimensional model, or why I need to have a data cube? Because we said that for the data warehouse, the data must be stored in the form of multi-dimensional data model, but it is generally viewed as a data cube. Now the question is why? Please observe the table. Observe this table. So you have the employee name. You have the quarters. Quarters in the sense like 1 year will be divided into 4 quarters, right? 3 months as a quarter. So quarter 1, quarter 2, like that it is specified. Then these are the locations and what is the commission given for each and every employee, right? So this is a two-dimensional data model. Now imagine I want to find out what is the total commission, spent in quarter 1, what is the total commission spent in quarter 2. Along with that, I want to find out what is the total commission given for each and every employee. I think I make sense. This is a two-dimensional data I have. From this data, what I want to collect, what I want to summarize, I want to summarize what is the total commission spent in each quarter, and I also want to know what is the commission given or collected by each and every employee. So that is how this table is aligned, right? So in each quarter, the total commission spent is 3,500, 3,000 in the second quarter, whereas Alice has got 1,000, Bob has got 2,000, Mary 2,500, Jim 1,000, right? So this is how I want to summarize the data. Now, if you want to summarize a data like this, from this existing table, the problem is you have to write a query which is very, very complex. This is one single query. Imagine all of you know how to write a query in your database management system. So if you use your simple relational database management system, you need to write a query something like this. Now you can observe here the number of unions is exponential. You are having only 2 dimensions here. What are the 2 dimensions here? The quarter and the employee name. Quarter and the employee name. Imagine you are going to add the third dimension, location also. So if you are going to add the location dimension also, obviously this query is going to become more complex, right? So just for having 2 dimensions, what are the 2 dimensions I have used in this query? I have used the employee as one dimension, quarter as another dimension. just for having these two dimensions, the query is like this. If you want to add more dimensions, imagine what will be the complexity of this particular query. So it increases the complexity of a query if you start adding the dimensions for retrieving the data. So this will be leading to very poor performance in the relational database management. So relational database management system is using a relational data model, or it may be using sometimes hierarchical data model. Even though it is using hierarchical ER model or a relational model, the query complexity will be increasing. So that is why we don't prefer a simple two-dimensional data model for our data warehouse. Instead, we prefer multi-dimensional data model, which will be viewed as a data cube, right? So these kind of subtotals, right? What kind of subtotal you are going to do? I want to find out the subtotal for Q1, Q2, or I want to find out the subtotal for each employee. So these kind of subtotals are very, very common in the analytical processing queries, and you need to define new operator for collection of these subtotals, and which can be called as a data cube. So what happens in the case of data cube is you are going to have multiple dimensions, and in each dimension, if you are going to have, even though you are going to have 10 different dimensions, for each dimension I can find out the subtotal, because in a data warehouse we are not going to store the transactions. What do you mean by transactions? In the data warehouse, these data will not be stored. Remember, this kind of table will not be there in the data warehouse. The data warehouse is focusing on only the summary information, right? Summary information will be stored in the data warehouse. Whatever subject you are going to choose. If you choose the subject, commission is the subject chosen, right? In the same way, the summary of commission is stored here. So this is what the data expected in the data warehouse. So if it is going to be the sales based on the amount, then what is the sales amount for each quarter, that will be stored. So that becomes the subject of your data warehouse. So you choose a particular subject, and for that subject, what are the different dimensions available, and these dimensions will be stored as subtotals in the data cube. So that is why we prefer the data warehouse, which will be represented or which will be viewed in the form of data cube. Now, whenever I say data cube, it is going to be always a generalization. Why? We are not going to store the transaction data. Instead, we are going to store the summary data, right? So if it is going to be the summary data, I can say the data cube will be having the generalization of the cross-tabular values. What do you mean by cross-tabular values? You will be having more tables, right? More relations will be connected here. So based on that, you will be doing the summarization, or you may be using aggregation function. What do you mean by aggregation function? So in the previous example, we have found only the sum, right? Total. Sometimes you may want to find out the average sales happened in a particular location, or average sales happened for a particular item, or average sales happened in a particular branch, right? So these are the different dimensions you will be taking, and that is going to use an aggregation function called average, or it may be sum, or any kind of average function you will be using. And in the same way, different dimension hierarchy will also be used in your data cube. What do you mean by different dimension hierarchy? Say, you want to find out the sales report. Now, when you take the sales report may be based on year, or the sales report may be based on half yearly, the sales report may be based on quarterly, or the sales report may be based on weekly. So your time is divided into different hierarchy. What is the different hierarchy? From year you go to the next level, which is half yearly. From half yearly you go to the next level, which is quarterly. From quarterly you go to the next level, which is weekly. So that is what you mean by dimension hierarchy. You take one dimension, then divide it into different levels, right? So any data cube will be a generalization of combination of tables, or it may be a generalization in the basis of aggregation function, or it may be the generalization based on different dimension hierarchy. So this generalization will be generally happening based on different perspective. So what is the kind of analysis that you are going to do? Based on that, we will be having different perspective. Now when I say dimensions are the perspectives or entities where on which the organization is going to keep a record. For example, several perspective പറഞ്ഞിട്ടുണ്ടെങ്കിൽ നിങ്ങളുടെ sales report may be having a record about the location. Sales report may be based on branches. Sales report may be based on time. Sales report may be based on a particular employee, right? Or a sales report may be based on a particular brand. Suppose if you take Maruti Suzuki, you want to find out the sales report of a particular model, WagonR, or you want to find out the sales report of a particular model, say Maruti Alto 800 in a particular location. So like that, the dimension can have different perspective, like on which the organization is willing to what I say, like on which the organization wants to do the analysis. Based on that, the perspective of dimension will also be changing. For example, a shop may be creating a sales data to keep a record for the dimension called time, dimension called item, dimension called location, etc. Right? So all these dimensions will allow to keep track of the things. For example, what is the monthly sales of a particular item? What is the yearly sales of a particular location? Right? And each dimension will be having a table related to that. That is what you call as a dimensional table. Please make a note of it. For each dimension, you will have a table, or you call it as relation. And this table is what you call as dimensional table. Right? So the dimensions are the perspectives or entities with respect to what an organization wants to keep records, and each dimension will have a table associated with it, which you call as a dimension table. So the dimension table will be describing a particular dimension. So your dimension table can be specified by the users, right? When I say users, these are the users of analytical processing tools, not your transactional processing or a data entry operator. They are the experts who is doing the analysis, or they will be in the executive level who wants to understand the report of a particular organization, right? So it may be specified by the users who will be using the analytical processing tool, or the experts, or it can be executives. And not only that, the dimensional table will be automatically generated and adjusted based on the data distribution. So based on the data distribution, the dimension table will be automatically generated. And when you take the multidimensional data model, it is organized around a central theme. We have already seen the data warehouse must have one very important characteristic. What is it? It must be subject oriented. So subject is what you call as the central theme. And I think I gave you the same example of sales as one of the subjects for an organization, or it may be employees, or it may be branches. So on what you want to analyze, that will be taken as a central theme. But suppose, say for example, an organization wants to open a branch, right? It wants to open a new branch in particular location. So what it will be doing, the central theme for analysis will be taken as location now. It will find out what is the sales in that particular location, what is the item that is moving in that particular location, in the particular location, how many customers are coming from that particular location, what are the limitations that are available in that particular location. So based on that you will go for analysis, and after analysis you can decide whether a new branch can be opened in that location or not. So your multidimensional data model is organized around a central theme, and this theme will be represented by the fact table, right? So understand here, your multidimensional data model will be based on dimensions and facts, right? It is generally defined by dimensions and facts, and these dimensions will be stored in the dimension table. The same way, the theme or the subject will be represented by the fact table, and all these facts will be numerical measures, and these are the quantities by which we want to analyze the relationship between the dimensions. So when I say the facts are the numerical measures, it is going to be the summary value, summary based on one particular dimension, which will be stored in the fact table. We will be seeing the example also, don't worry. What you have to understand here, first point, the data warehouse and the online analytical processing tools requires the data only in the multidimensional data model. Why? Because the two-dimensional data model will have a very complex query if you want to have the summarization. So to overcome that difficulty, we go for the data cube model. And the data cube is the easiest way of representing all the generalization information. And the generalization can be from different perspectives. And these perspectives will be represented as dimensions. So obviously the multidimensional data model contains dimension table. Since the multidimensional data model is organized around a theme or around a subject, it will be represented by the fact table also, right? So these are some of the examples of the facts that you will be having. The sales will be taken as a theme, but the sales will be represented in amount, or the sales can be represented in number of units sold, or it may be the amount budgeted, right? So you want to analyze based on the sales, or sales in based on the amount, or you want to analyze the sales based on number of units sold, or you want to analyze based on the sales which is based on the amount budgeted, right? In the same way, when you take the fact table will be containing the names of the facts, right? When I say fact, whether dollars sold, units sold, that is what you call as names of the facts, and what is the measure, right? So dollars sold in this particular quarter, the amount will be represented as 1 lakh dollars. Like that, it will be mentioned with measures also. And it will also have the keys to different dimension table. I will show you an example. So this is how your multi-dimensional data model looks like. These two are called as fact table. These are the fact table. So what is highlighted here? These are the fact table. and these are the different dimension table. Right? What are the two facts I have taken in this example? One is the sales, right? One central theme is taken as sales. Another central theme is taken as returns. So, how many quantity have been returned for that particular product? Here, how many products have been sold? So, sales report and the returned items. So, for each sales fact, different perspectives are taken. What are the different perspectives taken? The different dimensions. One dimension is the sales based on the product, the sales based on the stores, the sales based on the time. Correct? So, these are the three dimensions considered for one central theme, which you call as sales. So, this is what you call as the fact table, and these are the three dimensions taken for the theme, which is represented as dimension table. Now, another fact taken is returns. So, this becomes the fact table for return. And what are the three dimensions taken for returns? Based on the product, based on the store. So, how many products have been returned? How many stores have the returns? And what is the reason for returning? So, these are the three dimensions we have taken for the return fact. This is how a multi-dimensional data model will be represented. That contains the central theme in the form of fact table and the perspectives, right? The central theme is based on different perspectives, which you call as dimension, and these dimensions are represented as dimensional table. So, this is how a multi-dimensional data model will be represented.